Yeah, good afternoon. I hope you had a nice lunch break. Yeah, I'm going to talk about Symfony 7 today. First of all, who's this guy talking to you here? My name is Alexander. Yesterday I got a complaint that my name is not on the introduction slide. Maybe I will revise the slide, but in the meantime, my name is on the bottom right corner on every slide. I'm a freelance software developer. I usually use PHP and Symfony in my projects, and yeah, I like open source, so I do contribute back to all the libraries that I'm using if I find something that should be contributed back there. I think I annoyed some of the maintainers a bit too much, so I got commit rights and joined the core teams of the Symfony and Doctrine projects. I like code that has aged like a good whiskey. And in my free time, I maintain 4 long-term support releases. So today we're talking about Symfony. So I guess that everybody who's in the room knows what Symfony is. Otherwise, the new features of Symfony 7 would be quite boring for you. So Symfony, for the record, is a framework of PHP web applications, but also a set of reusable components. So even if you don't use Symfony as your framework, you can still use the components that I'm talking about today. Also, if you are using a different framework, chances are that some Symfony components are buried deep down under the hood. So Symfony 7 is our next major release. The beta 1 release is out already, and the final release will be released by the end of November. We have time-based releases, so this won't be delayed. Whatever is ready by the end of November will be released. So if you have a Symfony application and can already test with the beta releases of 6.4 and 7.0, then you can participate in stabilizing this release. So this slide contains all the new features that Symfony 7 brings to you, which is the amazing number of 0. So why is that? Major releases are pretty boring for Symfony, and also pretty exciting because they are kind of a new start. We usually ship new features in minor releases. So we also released the version 6.4 by the end of November, also beta 1 available already. And this will ship all the new features that are currently under development. And our major releases are mainly for cleanup. Is there a question? OK. The 6.4 and 7.0 releases will be or will have the same feature set, except for the fact that Symfony 7.0 won't ship the deprecated features. And every 2 years, we also release a long-term support release, which will be maintained for a longer period of time. So as you can see on this schedule here, our current long-term support release is 5.4. So if you are on this release, yeah, that's okay-ish, I guess, because you will still get bug fixes for that, and you will still get bug fixes for another year. And yeah, so if you are looking for a stable release that you don't need to update that often, then this is probably what you want. If you have an application under active development, then you should probably use the feature releases, which is currently 6.3, and the next one will be 6.4, which is also our next long-term support release. Kind of the reason behind this schedule is that upgrading to the major version because of because of the removed deprecation layer can be a bit difficult and might take some time because you have to adjust your application. Your dependencies also have to adjust to the new major version. So it could take a while to actually do the upgrade, depending on how much you are affected by the deprecations. This is why you can stay on this 0.4 release a little longer. Yeah. So since we are not talking about the new features of Symfony 7, obviously, the talk is now Symfony 7.0 is here. So what happened since the release of Symfony 6.0? So because every feature that we shipped in 6.1 until 6.4 is actually one of the new features of Symfony 7, because this is actually our feature development timeframe. So I'm going through quite a lot of features here. If you have questions about one of them, please raise your hand and ask a question. Because when we do this at the end, then I have to jump to an early slide or something, and everybody has forgotten already what the slide was about. So feel free to ask questions whenever you want. So the Symfony 7 release is kind of a tribute to one of the features that I really like most about PHP 8, which is the addition of attributes to the PHP syntax. What we had before was this syntax we see on top here. The idea is that we want to instead of keeping configuration in separate configuration files, we want configuration to be annotated directly onto the classes that they configure. In this case, I have a controller class, and I want to attach a route to this controller class, because without a route, a controller class would do nothing, and without a controller, a route is in most cases pretty useless. So those two things belong together, and I think it is reasonable to have them in the same place. But the problem about the syntax on top here is that we still need an external dependency for that. This external dependency has to parse this comment block over there, and this is basically something that the language kind of ignores. It stores whatever is in there inside reflection, and we can fetch the content verbatim, but there's nothing parsed in there, so we have to attach our own parsers. And there are also other libraries that define a syntax for those blocks, which kind of conflicts with the doctrine annotations library. So those libraries have some workarounds in place that they ignore doctrine annotations, and doctrine annotation has some workarounds in place that they ignore other libraries' annotations. So this was kind of a mess, but it was a mess that kind of worked. But PHP introduced this native syntax here, which can be queried through reflection, and we don't need an external dependency for this anymore. This is a syntax that that is being passed on language level. So this is in every way superior to the previous approach. So we pretty much like this, and we have migrated everything that used doctrine annotations previously to attributes. Currently in Symfony 5 and Symfony 6, this route attribute, for instance, can be used as a doctrine annotation still, but can also be used as an attribute. So you have the possibility to switch from attributes from annotations to attributes at your own pace if you want. But now that attributes are here, we kind of thought, how could we make use of them a little more, now that using them got a little less complicated. So yeah, this is probably what you know already if you have been using doctrine annotations previously. We can use it for routing, we can use it for validation. So basically every validation constraint is also an attribute or an annotation. And we can use it to configure the serializer, for instance, to configure a serialization context that should be used when serializing a given class, or to annotate groups on this, or to mark a property as ignored, that the serializer should not pick it up when serializing or unserializing data. And so this is what was already there. And this works with attributes now as well. So we thought a bit about how can we make use of them in the dependency injection component, because dependency injection component over the years has also evolved from I have to configure all my services in a large configuration file or many large configuration files towards, hey, if I can look at the constructor and the constructor has typed arguments and I already have a service for a given type, why should I configure this explicitly? I can simply auto-wire this, right? So this is a big step that the dependency injection component did like in version 3 or so. And yeah, now we thought about more ways how we could reduce the need of still writing configuration files for dependency injection. And one of the concerns was service decoration. So for instance, if I have a very special serializer that I want to use instead of the one that Symfony provides, and this special serializer simply decorates this, the Symfony one, so it adds features to it. Maybe it logs everything that is being serialized or something. This is something that you can do with the decorator. Then this would probably look like this, plus the implementation of the methods, of course. Such a decorator is supported by the dependency injection component, but until now you have to configure this in a configuration file. We have added attributes for this with Symfony 6.1, and we renamed one of the attributes in 6.3. So yeah, this feature was kind of revised afterwards, but still this is the current syntax. So I can say if this service here, if it's being picked up by the dependency injection component, it should act as a decorator of the serializer interface service, and the decorated service itself should be, oh, I can paint on this, right? So I don't have to point. The decorated service itself can directly be injected here. So no need to configure this in a configuration file anymore. I can do this now with attributes. Also auto-wiring stuff. So if I cannot auto-wire something by type, then I have an attribute now that I can use for that. Here the first example. I have probably multiple implementations for this API client interface, and I want to inject a specific one. So this is what I do here. This is supposed to be an arrow. I can do better. Arrow. Nice. So maybe in my tests I have a mock implementation of this API client that I want to inject, but if my service is wired for use inside the application, then I want this service to be injected and not the mock one. Something that I also commonly need to inject is kernel parameters, like for instance here, the project directory. I can also indicate this through this attribute here by simply saying I want the kernel project here. I can also use an expression here. So if I want some subdirectory of the project directory, I can use an expression here with this percent notation that you probably know from the configuration files. This also works, and I can also auto-wire the content of a environment variable that also works here and also makes the container actually fail if the environment variable is not present when running the application. So what else? I'm done here. What's there? Yeah, this is wiring closures. So this service here has two closure arguments, two closure parameters, and closures is something that we could not auto-wire previously because everything could be a closure, and which closure actually should we inject here. So what I can do here is, for instance, in the first example, I have a dependency that is probably heavy to construct, and I don't need it all the time. So I can inject a service closure here, which is basically a closure that I can call to actually give me the service. This is what we see here. The service, when we use it the first time, we call the closure. So the service is stored in our property, and then we can use it. So unless the do something method is called, the service or this dependency wouldn't be constructed. The alternative to this is defining this service lazy, which then would give me a proxy object. But this is, I think, a bit clearer. The laziness now is, you can see it that we get a lazy closure here. The other thing that I like, especially when working with legacy code, is the second one. When I have a class that is being used as a service that still has a lot of static calls in there that I want to make mockable, then I usually replace those with closures. And I can do this very easily now by saying that the static call should be injected as a closure, and then it is available in my method. So when I'm testing this class, I could inject any closure I want as a replacement for the static call. So the static call is being made mockable here. So what else? Yeah, we can take this one step further. In this example here, I also have the auto-wire callable attribute that I used in the previous example. But here, I'm not wiring a closure, but I'm wiring an interface. So the interface here has only one method. This is the only case in which this actually works. And what I get now is a proxy object that implements this interface. And when I call the method on that interface, the call is being directed to the closure that I configured there. So in this case, I said I have a expander service that is fetched from some package, from some bundle, provides this to me, but the class itself doesn't adhere to the interface or doesn't implement it, but it takes the same parameters. I can simply say I want the expand template URI method from the expander service, and I want this call to be hidden behind the interface. I find this pretty neat, but I probably won't use it that often. But yeah. What else do I have? This is about service locators. So the dependency injection component has for a very long time the ability to provide you with a service locator that only contains the services that you want to be in there. So you have a class that receives a service container, but it doesn't receive the full service container of your application, but a reduced one. You could do this previously by configuring the service locator explicitly or by tagging all the services and then inject a tag locator for this. But you can do this now also with this attribute that you can simply say that I want a locator. The locator should have the services logger, router, and serializer, and I want those services to be auto-wired through those interfaces here. So if I call this services gets logger, then I will get the logger interface implementation of the application. So this was the dependency injection attributes for now. Now I get to some attributes for the HTTP kernel component, because also for the HTTP kernel component, which dispatches the request through a controller, we also thought about how could we make this a bit more enjoyable, and especially how can we remove common tasks from controllers that involve parsing the request object. Okay, we get to this part later. Sorry. In this case, we have a couple of attributes that configure the response actually. The first one defines cache headers. So instead of setting cache headers on my response object, explicitly, I can set them via this attribute. So in this case, this configures all the responses that are being returned by this controller with the cache headers that I've placed up there. This makes it probably a bit more obvious which cache headers this controller returns or sets. And it's also powerful in combination with the second attribute, with the template attribute. You might know this if you have used the framework extra bundle previously. It's not like one of our favorite attributes, but it was kind of popular, so we decided to keep it. The template attribute allows you to render a template without actually depending on the Twig engine. So I can simply return an array of template variables, and I can annotate which template should be rendered for this controller. And then if the controller only returns this array, then this array of parameters will be passed to the Twig environment in combination with this template that I've annotated there, and then this template is going to be rendered. It makes the controller a bit smaller, especially if this is something that you often need, that you render a lot of templates, or you have a lot of controllers that all need to render a template, but you don't want to depend on the template engine itself. Then this is probably something that you can use. Yeah, now we get to the part where I don't want to pass the request anymore. This is about getting parameters out of the query string of the URI. When matching parameters out of the URL path, then it was already possible to directly get those parameters as arguments to my controller. But for query string parameters, this was not possible yet. So we added a small attribute that we can annotate a parameter with to indicate that we actually want the content of a given query parameter to be injected here. This is also something that was not possible with doctrine annotations, because doctrine annotations did not allow us to annotate function parameters. This is something that attributes allows us to do. This also performs validation on this. So if I ask for the parameter IDs and the parameter IDs is not present, then we will return a HTTP 400 or 404, I'm not sure, to the client. So the controller would not be called in this case. Also, if the IDs parameter is not an array, but a string instead, then this would also raise an error, a client-side error. This also spares us some input validation in this case. And if we indicate parameters as optional here, then they don't have to be present in the query string. All right. Time. Okay, looks good. So this is about JSON payloads that are being sent to my controllers. So if I were to parse and hydrate this DTO object from a request, that is, if it's this DTO object is supposed to be posted to me as a JSON payload in a request, and if I had to parse this, then I would have to fetch the JSON string from the request, funnel it through the serializer, perform validation on this, and then I actually have the DTO in my hand that I can actually work with. And since this is a very common thing to do, especially when you're developing an API, we have added an annotation there, map request payload, that indicates that this argument here should be fetched from the request body, and you can also see that the DTO here contains some validation constraints. So if the DTO that is being posted to me is not valid according to those constraints, then the client would also receive a HTTP 422 error. So this is also something that would not hit my controller. So if I receive a DTO here in my controller, then I can be sure that it was well formed, then that it was valid, and that I can directly use it as it is. Also, handling exceptions was a bit improved. If I have like a specific exception, a domain exception that comes from my application, and I know that whenever this exception is being raised, I know that a 404 page, for instance, should be displayed. Then at the moment, I would have to attach an event listener to the kernel exception event, and then change the status code of the exception that is being rendered. Or there was a big configuration file where I could configure a mapping from exception classes to HTTP status codes. I don't need either of this anymore. I can simply annotate this to my exception class and say if this exception is being raised and not handled by my application, then please turn this into a 404 and also write a log entry with the debug log level. Okay, I need to drink something. I'm talking too much. This is an attribute that you might already know if you have worked with the framework extra bundle as well. This basically says any route that hits this controller can only be accessed by people that are authenticated and that have the admin role. And if this authentication or the authorization fails in this case, I don't want the user to know that this route even exists. So I want a 404 exception to be raised instead. This is an annotation that was pretty popular in the framework extra bundle, and we moved it to the core now. Okay, I've talked a lot about the attributes and how we work with them and how we like them and how we like them more than doctrine annotations. So this is probably inevitable now that we throw out doctrine annotations completely in Symfony 7. So they still will work with Symfony 6.4. You will get deprecation notices if you use one of Symfony's doctrine annotations, also if you use Symfony's annotation reader service. But in Symfony 7, this all won't be present anymore. So if you have a Symfony 7 application, you can only use Symfony's attributes as attributes. If you have another library that requires doctrine annotations, or if you have your own doctrine annotations, you can still configure your own annotation reader and use it to read those annotations. This is still possible, but Symfony won't provide you with this service. You have to configure the service yourself. This is probably a heavy one for some applications that have been using doctrine annotations for a very long time. I had some good results with a tool called Vector that can migrate code bases or modernize code bases. And this tool is also able to rewrite doctrine annotations as attributes. And using that tool on route annotations or on serializer annotations or on validator annotations works pretty well for me. So it might seem heavy at first, but leveraging this tool should probably help you getting ready for Symfony 7. Also, the other inevitable thing is the framework extra bundle is going to die. Since we've moved all the annotations that we want to keep into the Symfony core, there's no reason for us to keep this bundle anymore. And this bundle was, I kind of didn't understand anymore why this bundle even exists, because it contains features that were so popular that every Symfony application used this bundle or depended on it. and it was not even in the Symfony namespace. It was in the Sensio namespace. So we decided to sunset this bundle and move everything that we want to keep into the Symfony core. So if you're using this bundle and if you have a Symfony 6 application, you should be able to replace all the annotations that you use from this bundle with annotations that Symfony provides natively, and then you can simply remove this bundle from your dependencies. So now some improvements of the security component. Finally, access token authentication. So authenticating your application with an access token is a pretty common thing to do. Until now, you had to write your own authenticator for this, which was not complicated, but everyone who had to write that authenticator had to write like common parts, like how do I extract the token from a request, how do I resolve a token to a user, and there were documentation on this, and you could copy and paste some code snippets there, but we wanted to add or improve this experience a bit and add an authenticator that guides you a bit through how to use a token-based authentication. So this, you see here an example HTTP request. Here the access token is sent through the authorization header, which is pretty much standard. I realized that some applications or some protocols decided to move this token into the query string or the request body. So this is why we made this configurable, that you can extract this from anywhere you want. But the default is that you will fetch this from the header. So how does this look like? I can configure my firewall like this. I can say I want to have access token authentication, and the only mandatory thing that I have to configure here is a token handler. And this token handler basically teaches Symfony how a given access token, which is a simple string, can be validated, and how this access token can be resolved to a user ID. And I can optionally also configure how the token is extracted from the request. I have 3 built-in ones, which is a header, and if I leave out this block entirely, as I said, header is the default. But there's also query string, which looks for an access token parameter inside the query string, and also request body, which looks for a access token property either in a form submit or in a JSON payload. And if all of these don't work for me, I have the possibility to add my own extractor and then just reference this here by service ID. I would recommend, if you're developing a new application and want to use access token authentication, then just stick to the header. It's the most standard one, and probably also the one that causes the less friction. So this is how this token handler looks like. You have to implement one method here, which is called getUserBadge from access token. So this simply receives the access token as a string, returns a user badge, which is, no, this should be a user badge here. Yeah, I will correct this on the slides before I submit this to the organizers. Right, so this method is available since 6.2 already. Then we have built upon this by implementing OpenID Connect, which is a fairly popular method of authenticating users through access tokens, which involves an external authentication server. So instead of implementing a token handler that understands how OpenID Connect works, you can simply configure this either by configuring the user info URL where the configuration can be fetched, or by explicitly configuring the parameters for OpenID Connect. So another thing that we've built is a profiler for the authentication process. So if you authenticate a user, for instance, with a login form, then you generate a couple of badges. This is how the current authentication system works. And the badges basically say, I have, in this request, I have found the user with the current ID, or with this ID. I have found the following credentials. I have found this CSRF token, and maybe more badges that you define yourself and for which you define your own resolvers. And this profile integration basically tells you why the authentication failed. So in the case above, you can see that the CSRF token, for instance, was not correct. Wait, let me see, I have more of this. Okay, this was the security part. Then next up, some new components that have emerged during the 6.x releases. First of all, we have added a HTML sanitizer. So if you have to work with HTML code that is contributed by users or comes from another doubtful source, then and you want to render this HTML inline into some other HTML, then you have to sanitize it first, which means that you have to throw out tags that you don't want, or that you have to escape certain parts, or even that you have to correct certain parts. And this is not a trivial thing to do, as you can see in these examples here. In both cases, I have a HTML tag that has not been closed properly. So I want the sanitizer to fix that, but it depends on the context how the proper fix looks like. In the first example, you see that the proper fix is simply to add the closing tag. And in the second example, you can see that the HTML code shouldn't be there, because inside of a text area you shouldn't have executable or literal HTML code, but it should be escaped there. So in this case, we are not fixing the HTML, we are just escaping it. You can configure the sanitizer. You basically give it a allow list of tags that you want to keep, and everything that you don't want to keep is being stripped out of the HTML string. We have added a clock component. This was added because there was a PSR standard that was published, which defines an interface for a clock. Basically, this interface just has a now function that gives me the current date and time. The idea behind this is that you want to make code testable that depends on the current time. For instance, I have a certain service, a theming service, that should render a template differently, or should render a different template during Christmas. Then I would like to test this, and I want to be able to test this no matter if it's Christmas currently, or if we have Easter, or if we have a completely different date and time. So I want the actual service, when it's being run inside my application, to depend on the current date and time. But when it's run in the context of my tests, I want to replace the clock with a clock that I can control and that emits only exactly the date and time that I want. We have extended this interface a bit. You can see a service here that depends on the current time, but it also depends or it also makes the clock sleep. If I would have a clock that only emits a fixed date and time, then this output here wouldn't be correct anymore, because if I have a clock that emits the same date and time every time, all the time, then I will have a JSON response where start and end are the same, and I would expect a response where start and end would be 5 seconds apart. this controller doesn't make much sense, but it's just to illustrate the problem here, that I want to be able to test a piece of code that actually performs a sleep. And I don't want the test to actually sleep for 5 seconds to test this. And I also want to make sure that the date differs before and after the sleep. So our clock has also a sleep method. And if I inject my mock clock in here, then this mock clock wouldn't actually sleep for 5 seconds, but instead advance its internal date and time by 5 seconds. So that the test would run pretty fast, and we would get the expected result that the two dates are 5 seconds apart. Oop. The clock component also provides me with a date point class, which is a stricter and mockable version of PHP's datetime immutable. The problem that this class solves is basically that if you create a datetime immutable from a format and you put in bullshit there, then you would get false, which is kind of strange because in other situations we would get a proper exception. For instance, if you call the constructor of datetime immutable with a date that cannot be passed, you would get an exception. But in this case, you would simply get false, and you have to check for false. And this is something that you could easily forget. So what our implementation does instead is it raises an exception. The other advantage of this class is that it's linked to our clock. So if you call the constructor of the datePoint class, then you would receive the dates that our clock would give you. So you basically can mock the constructor of this datePoint class, which is helpful if you have no control over the constructor call itself. So if you're testing a piece of code where you cannot inject a clock into, then this is probably a nice addition. What else do we have? We have the PSR HTTP methods bridge. This is technically not a new component. This bridge has existed previously, but it became a bit more popular than we anticipated. So we moved this into the Symfony core. So just to recap, if you or if you haven't used this bridge before, there's a standard for request and response objects, which is called PSR7, and this standard was developed after Symfony has developed their own abstraction for requests and responses, which was the HTTP Foundation. And since the PSR7 standard was so incompatible to HTTP Foundation that we cannot simply migrate towards that standard without throwing away the whole component, Symfony infamously decided to not adopt the standard, but to develop this bridge instead, which allows you to convert HTTP Foundation objects to PSR7 objects and vice versa. So if you use this bridge, what allows you to do is you can write controllers that don't receive a Symfony HTTP Foundation request, but instead a PSR7 server request. And those controllers can also return a PSR7 response, and this will then internally be converted back to a HTTP Foundation response. So it kind of allows you to write controllers that are kind of framework agnostic, that don't depend on Symfony's HTTP abstraction anymore. And it also allows you to use libraries that use PSR7 to identify request and response. So if they don't support HTTP Foundation, you can use the bridge to convert the object and then call that library. A small recap if you haven't used that component yet. Symfony has a component called Messenger, which is basically a abstraction layer over message queues, and it allows you to dispatch or move heavy tasks into the background, and then you have a worker process that listens to the queue and that receives those messages and can perform tasks without blocking your HTTP process. If you haven't used this component yet, please do. I pretty much like it. Why am I telling you this? Because we have built a couple of new components that build upon this infrastructure. The first ones are webhook and remote events. So webhook is a common pattern for receiving notifications from external systems. For instance, if you have used some kind of chat like Slack, for instance, if you would build an integration for Slack that some bots or some notifications are being posted as messages in your Slack chat, then Slack exposes a webhook URL where you can post stuff to, and then it's being turned into a chat message. So if you want to reinvent Slack or build your own Slack, and you wanted to have such a webhook endpoint where you can post notifications to, then this component can help you with this. You basically have a single URL where all the webhooks are being posted to, and then you can have this webhook parser that can decide if it can parse anything out of this webhook, and then generates a remote event object that you can subscribe to actually handle this. And if you want the processing of those events to be asynchronous, you can also leverage the messenger for this. Another component that has been added was the scheduler component. Scheduler is basically a cron tab on steroids. So if you have repeated tasks, in this case we have a task that periodically checks if there are any users that approach our trial phase, the end of our trial phase, then they get an email. So this is something that has to be done regularly, right? So the scheduler would basically register itself as a messenger transport. So I can leverage my existing messenger infrastructure. I probably already have a worker process that listens to messages that come through my message queues. And this worker process can now also listen to this scheduler transport. So once a week, the scheduler transport would generate a message that this worker would then handle synchronously. Another component that we've added was asset mapper. This does a couple of nice things, front-end related things. For instance, I can specify a directory where I can throw in all my assets that should be published, and all those assets are automatically versioned. So if I then reference a asset here, in this case a duck.png, then a hash is being appended to the file name, so that this is for browser cache busting. So if I were to replace this PNG file, then the hash would change. For the browser, the file name would change, and the browser would see, hey, this is not in my cache, so I have to fetch it again. Of course, the asset mapper then makes sure that those URLs actually exist, and then it will serve your URL or your original file from the assets folder. And for production, you can dump all your assets with appended hashes to your public directory, so that the asset mapper is not being called for every request. What the asset mapper also does for us is it implements the import map API, so that you can also reference JavaScript files with such an import here. So I directly serve a JavaScript file to the browser that says I want to import the duck from duck.js, and then I can say I can define an import map. This basically would render the block below into your template, and tells the browser that assets duck.js is actually assets duck minus insert your hash here .js, and then the browser would know how to import this. This is an API that modern browsers implement, and this yeah, basically allows you to write modern JavaScript without the complexity of a bundler. So if you right now have Webpack to just take all your JavaScript files and compile them into a single JavaScript file and compress it and send it to the browser, then you wouldn't need this anymore. You could use this approach, and then your browser would do the bundling for you. The browser would then load the individual files and load them accordingly. This, of course, raises the question, why have you done this with the bundler in the first place? So back in the days, this was important because we wanted to reduce the number of requests that a browser would make to our server. And this was important while we had HTTP 1. But with HTTP 2, we can multiplex multiple requests through one connection. So the penalty for requesting a lot of files is not that big anymore, and browsers are also optimized for this. So the benefit that I would get from a bundler that packs everything into a single JavaScript file or into multiple JavaScript files that can be loaded is not so large anymore. So if you have just a small bit of front-end code and don't have like a fully fledged front-end framework that has specific opinions on how your code should be compiled, and you have developers that are not that into front-end development and just want to use a little bit of JavaScript, then this is probably a nice approach to get rid of your Webpack pipeline. It also allows you to add external packages to your import map. So it basically has commands that look like the commands that you know from Composer. So I can, in this case, require Bootstrap because I want to use Bootstrap for rendering a nice front end. And this will then add or download those files, add them to your assets folder, and also add them to your import map. And you can also run this command to install those. So this command would then read your import map and install all the assets that are being specified there. And you can also use this to update all of the external assets that are referenced there to the current versions. So. But we did not only add components, we also removed some. I don't know if any of you remember the templating components. It used to be an abstraction layer for templating engines, while Symfony always used Turek as its favorite template engine. It also contained a templating system to write PHP-based templates. We have already deprecated and removed all integration for this component, I think with version 5 or so, and the component was still there. You could still use it if you wire everything on your own, and it still works. But we don't add new features to this. We noticed that we don't add new features to this. So this is why we are phasing it out now. This doesn't mean that this component will cease to exist immediately. It will still be released as a version 6.4, and version 6.4 is a long-term support release, so it will still be around for 3 years or receive bug fixes and security fixes for 3 more years. But we don't really want to maintain it beyond that. So if you are using that component and maybe you want to give it a new home, then please feel free to fork it. So I have a couple of smaller features, but looking at the time, I think I'm going to skip them. So if you want to learn more about features, because there were a lot that I couldn't mention here because I only have 1 hour, we have a blog that you can follow. It has a category called Living on the Edge, which announces all the features that we have added in a minor release. So yeah. Also, I got most of my information from this blog, which takes you to the last part, the horrors of framework migrations. because we all know that framework migrations have to be painful. There's no way around it. But I believe that Symfony does a good job at making it a bit less painful. So let's have a look at how you could make your application ready for Symfony 7. So as I've said earlier, Symfony 7 is basically Symfony 6.4 minus the deprecation layer. So if you fix or if you remove every usage of deprecated code paths inside your application, then you have a pretty good chance that Symfony 7 will just work. So how can you do that? First of all, you can check the upgrade notes. In this file is being kept up to date for the 7.0 branch. Just look in there and you see categorized by component what we've changed there and what are the breaking changes. But nobody reads that, right? So if you want to check your application, then the first thing you can check is the deprecation log. So if you look into your profiler or into the log files that are being emitted by your application, then you probably have seen already deprecation notices. But since your application still worked, why should you bother? So this is the point where you have to bother, because if you don't fix them, the upgrade won't work. As you can see here, I have the deprecation here regarding the document annotations. So I deliberately added back the document annotations library to this application and changed back one attribute to an annotation, and I immediately get a deprecation on this. This is the kind of deprecation that a static analysis tool can probably not really find out, especially when it's about how the annotation reader is being configured and everything. It's because the class itself that is being used as an annotation there is not deprecated. We keep it. We just deprecate using it as an annotation. So this is where runtime annotation or runtime deprecations are really helpful. But beyond that, there's also static analysis. So if you're using PHP Storm, for instance, and you use a deprecated class in here, or deprecated interface trait, whatever, then PHP Storm would already strike out the class. This means that you should be aware that you're using something that will go away eventually. And if you hover over this, then you get also a nice message telling you what you've done wrong here and what you should change. In this case, I've used the container-aware interface and the container-aware trait that will be removed both in Symfony 7. And below here, I have the output of a static analysis tool called PHP Stan. PHP Stan has a plugin called deprecation rules. And if you run PHP Stan with that plugin, then it will find deprecated code usages, like if you use a deprecated interface or a deprecated trait or a deprecated class, or call a deprecated method, you name it. PHP Stan will see that and will notify you about this. So this is also a way to find out what you need to change in your application. Also be aware that your dependencies might not be ready yet. So check if the dependencies that you use that also use Symfony components internally, if they are compatible with Symfony 7. If they are not, find out if there's a new version available that maybe is already compatible, or maybe they fixed this on some development branch already. And if both of this doesn't apply, then your dependency is probably open source as well. So just help your maintainer getting ready for Symfony 7. And yeah, when you have no deprecations left, just upgrade and see if it works. Run your tests. And yeah, maybe you're done. Also, if it doesn't, as I said, you're not in a hurry. Symfony 7 doesn't provide any features that Symfony 6.4 doesn't provide. It's just that it makes you ready for the upcoming feature releases. Symfony 7.1 would be the next feature release, which will be released by the end of May. So if you want to have the features that are coming with Symfony 7.1, you should probably see that you can upgrade during the last half of the year or the next half of the year. So to sum this up, Symfony 7 is there. It will be released soon. You can use all the new features already in 6.4. You can prepare your applications right now. I would suggest that you test out our beta releases and give feedback. And if you find something that doesn't work as it's supposed to work, and you can fix this yourself, then please send a pull request. Because Symfony is open source, Symfony is your framework, and we need contributions, and we need your contributions. And yeah, this is our GitHub page. You probably know it already. If you can improve Symfony, then we are happy to accept any pull request that does so. Then thank you very much for your attention, and I think we don't have really much time left for questions, but you can find me afterwards and ask me anything you want. Thank you.